This is part 2 of a review of Riemann sums and basic integrals. If you did not see part 1, you can either click the link that appears in the upper right hand corner or find the link in the description. If you appreciate this content, please give it a like. Number 7. F is a concave up decreasing function. Which of the following approximations would give an underestimate of the area under the curve? Here's an example graph of f of x that is concave up and decreasing. Will LRAM give an overestimate or an underestimate? LRAM stands for left rectangle approximation method, so we need to use rectangles that are drawn such that the left side of the rectangle ends right on the curve like this. We are trying to estimate the area under the curve. Notice that this rectangle includes some area that is above the curve. So this will give an overestimate, not an underestimate. So I'm not going to circle LRAM. RRAM stands for right rectangle approximation method. So we need to use rectangles that are drawn so that the right side of the rectangle ends right on the curve. We can see that RRAM will give an underestimate because this rectangle is leaving out this yellow area that is under the curve. So I'm going to circle RRAM as being one of the approximation methods that gives an underestimate. TSAM stands for trapezoidal sum approximation method, and the trapezoids are drawn like this. We can see that this trapezoid includes a little sliver of area that is actually above the curve, not just under the curve. So this is an overestimate. So we will not circle TSAM because we are only looking for the ones that give an underestimate. So the answer is B. From among these three, only RRAM gives an underestimate. For the sake of completeness, let me mention the other approximation method called MRAM, which stands for midpoint rectangle approximation method. We do not answer directly whether MRAM gives an overestimate or an underestimate. We don't draw a picture of MRAM. Instead, we memorize that MRAM does the opposite of TSAM. So we draw the trapezoid, we saw that it was an overestimate. That means that MRAM will automatically be an underestimate. Number 8. Which of the following is an antiderivative of 8 over x to the third power? I recommend a rewrite. 8 over x to the third power is the same thing as 8 times x to the negative 3 power. Now we can use the power rule of integration, which says that for the antiderivative, we add 1 to this exponent, and that gives us the negative 2 power. Then we divide the existing coefficient by the new exponent. 8 divided by negative 2 is negative 4. So which one of these is equivalent to this? Well, having a negative exponent drops you down to the denominator. So this would be the same thing as negative 4 over x squared. So the answer is A. Number 9. Find the definite integral from 0 to 2 pi of x minus cosine x dx. We can take the antiderivative one term at a time. The antiderivative of x will be 1/2 x squared. The antiderivative of cosine is sine. So this will be negative sine x. When I ask myself what the antiderivative is, I ask myself the derivative of what will give me this. And the derivative of sine is cosine. So sine is the antiderivative. This is a definite integral. So instead of putting a plus c on the end, we draw a vertical line and apply the limits of integration like this. To evaluate a definite integral, you plug in the top minus plug in the bottom. So here's the antiderivative with the upper limit plugged in, and then minus the antiderivative with the bottom limit plugged in. The terminal side of a 0 radian angle is on the positive x-axis. So is the terminal side of an angle of 2 pi radians. Either way, the sine will be the y value of this point on the unit circle, and the coordinates of this point are 1, 0. So the sine of 0 and the sine of 2 pi are both 0. All three of these terms have a value of 0. So the answer will just come from this first term. So we have 1/2 2 pi squared is 4 pi squared. Half of 4 is 2. So the answer should be 2 pi squared. So the answer is D. Number 10. Evaluate the integral from -2 to 3 of the absolute value of x minus 1 plus 1 dx. Use the graph of the function which is given, but be aware that on the AP exam, you would not be provided with this graph. You would have to sketch it yourself. I'm just being nice. The integral of a function from -2 to 3 is the area under the curve from -2 to 3. We can figure out these areas geometrically. Let's divide the area up into shapes that we know. For example, this rectangle, actually I didn't even need to draw two separate rectangles, did I? I can make one long rectangle which has an area of 5. What about this triangle here? I like to think of this triangle as half of a square. I can tell that this square that would be completed like this, this square has an area of 9. So the triangle will be half of 9, which is 4.5. This triangle is half of a square that goes like this. So the square has an area of 4, therefore the triangle will have an area of 2. Adding these three numbers together will give me the value of the integral from -2 to 3. That's 5 plus 2 is 7, 11.5. Number 11. To find the integral of this expression, we should distribute the x first. So that will be the integral of x squared minus 3x dx. Now we can take the antiderivative term by term. Adding 1 to this exponent gives us x to the third power, and then dividing by the new exponent gives us a 1/3 in the front. Adding 1 to this exponent gives us x squared. Dividing by the new exponent gives us -3/2. And don't forget the constant of integration. But that's it for number 11. For number 12, we need to use our knowledge of reciprocal trig functions. For example, we know that secant x is equal to 1 over cosine x, and cosecant x is 1 over sine x. Since 1 over cosine x is secant x, then 1 over cosine squared will be secant squared x. So we have the integral of secant squared x plus 4x dx. And now we will take the antiderivative term by term. To take the antiderivative of secant squared, you ask yourself the derivative of what is secant squared. Hopefully you remember that the derivative of tangent is secant squared, so that's the antiderivative. So for the first term, the antiderivative is tangent x. For the next term, we use the power rule of integration. Adding 1 to this exponent gives us x squared. Dividing 4 by this new exponent gives us a coefficient of 2. And don't forget the constant of integration. So that's it for number 12. For number 13, we need to use a technique called U substitution. Let's let U equal everything under the radical. So U will equal x to the third power plus 4. For this process, we will also need U prime. The derivative of x to the third power is 3x squared, and the derivative of 4 is 0. So this is U prime. Next, we rewrite the integral, making this substitution. So we get the integral of x squared divided by the square root of u. Now here's the key. Instead of dx, in fact, let me make a little formula off to the side. Dx is always equal to du over u prime. So I'm going to make this substitution right now. So instead of the dx, I'm going to put du over u prime. But we just found that u prime is 3x squared. Notice that the x squared in the numerator will cancel out the x squared in the denominator. This 3 in the denominator can be brought all the way out to the front as a 1/3. So on the next step, we will have 1/3 times the integral of 1 over the square root of u. Instead of writing the square root of u, I'm going to put u to the 1/2 power, du. In this form, it's a bit easier to see that the 1 over u to the 1/2 power is the same thing as u to the negative 1/2 power. So now we have this. We can find the antiderivative of u to the negative 1/2 power using the power rule of integration. Let's add 1 to this exponent. So that's like adding 2 over 2, which is going to give us 1 over 2. So we will have u to the 1/2 power. But then we need to divide by the new exponent. Dividing by 1/2, you multiply by the reciprocal, which is 2. Don't forget about the 1/3 that we still have in the front. And in fact, 1/3 times 2 just makes 2/3. And don't forget about the constant of integration. So this is the antiderivative with respect to u. We can't stop here. We need to take it all the way back to having x's again. Substituting x to the third power plus 4 back in for u gives us this. And this is one version of the final answer. Or you can just rewrite it with a square root instead of the 1/2 power. Here's another version of the answer. This is what you would probably find on a multiple choice question. To integrate number 14, we just need to simplify this first term. So first of all, I'm going to look at the square root of x as x to the 1/2 power. When you multiply with like bases, you add the exponent. 1 plus 1/2 is 3 over 2. With x to the 3/2 power in the denominator, this fraction would be the same as x to the negative 3 over 2 power. Now we can just take the antiderivative term by term. For the first term, we will do the power rule of integration. So I need to add 1 to this exponent, which is like adding 2 over 2. So I will end up with negative 1/2 for the exponent. For the coefficient, you do the reciprocal of your new exponent. So that will be a negative 2 out in the front. Now we need the antiderivative of secant tangent. You should be thinking the derivative of what is secant x tangent x. Hopefully you remember that the derivative of secant x is secant x tangent x. So this is the antiderivative. Just don't forget the plus c. So this is one version of the answer, or you could write your answer as -2 over the square root of x plus secant x plus c. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.